Hello, Algebra 2. Today we are going to talk about section 5.5, which is all about function operations. And by operations, I mean adding, subtracting, multiplying, and dividing. So what we're going to do today is we're going to take two different functions, think like f of x and g of x, and we're going to just practice doing these operations with them. So we're going to add them together, subtract, multiply, and divide. A lot of these operations we've already been doing in this class, so some of this will seem very familiar. For example, if you have two radical functions, we already know how to add radicals together and how to multiply them and so on. So some of this stuff will seem like review, but we're also going to talk about some new things, such as how to find the domain of that new function that we created after we've performed the operation. So let's go ahead and get started. So the domain of these functions, it's going to be the x values. We've talked about that before, right? That's what domain means. So for example, if I have a radical function, let's think of a square root function. We know square root functions look like this. The domain of something like that would be only the positive x values, right? Because this graph never goes into the negatives. It starts at 0 and then it covers all the positive x values. So to write the domain for that function, we would say x has to be greater than or equal to 0. And we also know that the cubed root function, that looks a little different, something like this. That one has a domain of all real numbers because there's no domain restrictions with a cubed root function, right? X is going in both directions. So now we're going to talk about how to find the domain of a new function that we create after adding or subtracting or performing some other operation. And the domain of those functions is just going to be the domains of both f and g. So we would take the domain of f of x and the domain of g of x, and we would make sure that our domain satisfies both of those. And then additionally, we're also going to have to think about whenever we divide functions, we do have to remember you cannot divide by 0. That's just one of those rules in math, right? You can't divide by 0. So if we are going to divide two functions, we have to consider that when we write out our domain. So we do not want to include x values for which g of x would equal 0. And we'll get into that more later in the notes when we cover division of functions. Okay, so let's go ahead and get started. We're going to start with adding functions together. And this one's pretty basic. To add functions, you just have to combine like terms. So this is something we've done before. So let's take a look at our first example. It says let f of x equal 5 times the square root of x, and then g of x is equal to negative 8 times the square root of x. And they're asking us to find f plus g of x. That just means add the two functions together. So let's go ahead and do that. Okay, so f plus g of x would equal f of x, which is 5 square root x, plus g of x, which is negative 8 square root x. And one thing that we have learned in this chapter, you can add radicals as long as the radicals match. So since this is a root x and this is also a root x, we can add those simply by just combining the coefficients. So 5 plus negative 8 is negative 3. So the answer here would be negative 3 square root x. Okay, so this problem also has us doing a couple other things. It says state the domain. So the domain of this function, there are a couple different ways you can think about this. You could think about this graphically. So if you're looking at both of these functions, these are both square root functions, and the resulting function is also a square root function. So if you think about that on a graph, that means that we only have the positive values for x, right? We also can see that this square root function has not been shifted left or right? Like there's nothing under the root here, so there's been no translations. That means it's going to start at 0. So we know that the x values are only going to be the values that are greater than or equal to 0. So that's our domain for this one. You can also think of this algebraically, and we were doing this with inequalities the other day, where you could just take what's under the root and then set that greater than or equal to 0, because we know that square roots cannot be negative. We can't have, on a graph, we can't represent the negative square roots because those are imaginary. So that would be the domain of this one. And then finally, we are asked to evaluate the function. So they want us to evaluate f plus g when x is equal to 16. That's what this notation here represents. It means evaluate f plus g when x is 16. So what we're going to do is just go over to what our answer was. Here was our answer, negative 3 times the square root of x. And you're just going to substitute 16 in for x. The square root of 16 is 4, so this would be negative 3 times 4, which is negative 12. So that would be the answer for this right here. We could say that that equals negative 12. Okay, we're going to do a couple more examples. So for each of these, we're going to do the same three things. We're adding the functions together, then we're stating the domain, and then we're going to evaluate that new function for that given value of x. So let's go ahead and look at number 1. Okay, so we're going to add the two functions together first. So we have the cubed root of 2x plus the negative 11 times the cubed root of 2x. So cubed root of 2x plus negative 11 cubed root of 2x. And once again, the roots match here, so we are allowed to add those together. Now remember, there is a coefficient of 1 on this one, so we're just adding up these coefficients. 1 plus negative 11 is negative 10, so the final answer would look like this. That would be the sum of those two functions. All right, now let's think about domain. Now, this is a cubed root function. So if you remember graphically, a cubed root function looks something like this, right? And those do not have domain restrictions. That would just be all real numbers. And again, just remember, anytime you have that cubed root function, you don't have to worry about the negatives being under the root because you're allowed to do cubed roots of negative numbers. So that means our x's could be anything. And then finally, let's evaluate it for negative 4. So we're going to take our answer here, and we're just going to substitute negative 4 in for x. Okay, so that would be negative 10 times the cubed root of negative 8. And we know that the cubed root of negative 8 is negative 2. So when you multiply those together, you would get positive 20. All right, let's take a look at number 2. So number 2, it looks like our two functions that we're working with, these are quadratic functions. So these are, we did these in a previous chapter. I see that there's an x squared term in each of these. So we're adding two quadratics together. So again, this is just combining like terms. So we're going to take f plus g. So we'll take this part here, 11x plus 2x squared, and we're going to add that to this part over here, negative 7x minus 3x squared. All right, and then we just combine like terms. I'm going to write mine in standard form because I always like to do that. I'm going to start with the x squared terms. If I combine those, we get negative x squared. And if I combine the x's, we get positive 4x. So that would be the sum of the functions. All right, let's talk about domain. So again, you can think of this graphically if you'd like, and if you want, you could take your graphing calculator and you could just graph this in your calculator. You could do that for any of these if you ever forget, and then you'll see visually what that graph looks like, and then you could write out the domain. But this is a parabola, and we know from a previous chapter that parabolas have a domain of all real numbers. Now this one is, it's not going to be centered at the origin, because it has this 4x here, but it doesn't matter. Even if it's shifted left, right, up, down, it's still going to have that domain of all real numbers. All right, and let's take a look at this. We're evaluating it at x equals 2, so we're just going to substitute 2 in for both of these x's. So negative 2 squared. Make sure that negative stays out of the parentheses there, because this is really like a negative 1 coefficient. Plus 4 times 2. This would give us negative 4 plus 8, which is 4. Okay, now we're going to talk about subtracting functions. It works pretty much the same way. So when you're ready, go ahead and turn the page and we'll keep going. Okay, so to subtract functions, you can just subtract them if you'd like, but the way that I like to do it is I like to distribute the negative, because then we can treat it as an addition problem. If you distribute the negative, then all you have to do is combine like terms. So that's how I'm going to be doing these. So let's take a look at our first example. Okay, so it looks like we have two cubic functions here. So if we're looking at f of x, it's 3x cubed minus 2x squared plus 5. Don't forget that plus 5. It's kind of too close to that word and there. And then we have the g of x function, which is also a cubic function. So we're going to subtract those. It says find f minus g of x. That means start with f and take away g. So I'm going to write that out. So we have 3x cubed minus 2x squared plus 5. And then we're subtracting the entire other function. So make sure you use parentheses there. So it'd be x cubed minus 3x squared plus 4x minus 2. Okay, and then again, the way that I like to do this, I just distribute that negative throughout here. So I'm going to change all the signs. Negative x cubed plus 3x squared minus 4x plus 2. And then I'm going to drop down the other side. And now we're just going to combine all the like terms. So I'm going to put mine in standard form. So I'm going to start with the highest exponent here. That would give us 2x cubed. And if I combine my x squared terms, I would have just 1x squared. Then I would put the negative 4x in there. And then finally combining the constants gives us a positive 7. So that would be the difference of those two functions. All right, now let's do the domain. So state the domain. So again, you could graph this in your calculator if you want to. If you remember from our polynomials chapter, this is a cubic function and they have a certain shape. So typically a cubic function looks something like this. It can look of various different ways depending on the transformations, but it typically looks something like this. And when you're thinking about the domain of a function like that, that domain would be all real numbers. All right, and then let's go ahead and evaluate it. So they want us to do, this should be a minus sign here. So we're going to evaluate f minus g for x is negative 2. So you're just going to plug in negative 2 in for x right here. So we have 2 times negative 2 cubed plus negative 2 squared minus 4 times negative 2 plus 7. Now, if you have a calculator, you could just type all that in your calculator if you'd like. I'm just going to do it mental math, though, because sometimes we have no calculator pages on our assessments. So I'm just going to do it the long way. We have 2 times negative 8 plus positive 4 plus 8 plus 7. All right, let's simplify a little further here. This would give us a negative 16. Negative 16 plus 4 gives us negative 12. If I combine the 8 with the 7, that gives us a 15. And if I add those together, that leaves me with 3. So the answer to that would just be 3. All right, let's look at a couple more examples here. Same thing, we're going to do some subtraction. So for number 1, we're subtracting, it looks like 2 cubed root functions. So let's start with f, cubed root of 2x minus negative 11 cubed root of 2x. And then since we have this minus situation here, that's going to turn into addition. So we have 1 of the cubed roots plus 11. So that would give us 12. So we have 12 times the cubed root of 2x. All right, and then domain, this is a cubed root function. And a cubed root function, remember, it looks like that S shape. So it doesn't have any domain restrictions. It would just be all real numbers. And finally, we can evaluate this for negative 4. So let's plug in negative 4. 2 times negative 4. So this would be 12 times the cubed root of negative 8. The cubed root of negative 8 is negative 2. So it would be 12 times negative 2, which is negative 24. Okay, and then number 2, we are dealing with those quadratic functions again. So we're going to subtract those. So 11x plus 2x squared minus negative 7x minus 3x squared. And then again, I'm just going to distribute that negative. So we have 11x plus 2x squared plus 7x plus 3x squared. And then combining like terms gives us 5x squared plus 18x. Okay, domain for this one, let's see, it's a quadratic. So it would be that parabola shape, which means we have all real numbers. And then we're going to substitute in 2. So let's see, we have 5 times 2 squared plus 18 times 2. 2 squared is 4, so this part right here would give us 20, and then 18 times 2 is 36, and then adding those together gives us 56. Okay, so now let's get into multiplication and division. So we've talked about adding and subtracting. It's pretty basic. You're just combining like terms for the most part. Now let's getting into multiplying. So multiplying functions is a little bit different, especially when you're working with radical functions or anything with exponents. You want to make sure that you're using your exponent properties to fully simplify these. So some of the things that we've learned in this chapter are going to come up when you do this. So let's take a look at our first one here. It says f of x is x squared and g of x is the square root of x. And we're being asked to find f, g. Since they're right next to each other, that implies multiplication. So we're finding f times g of x. So we're going to multiply these functions together. So here we go. So f times g of x would equal x squared times the square root of x. Now, because this has an exponent and this is a radical, it's a little challenging to multiply these together the way that they're written right now. So instead, I'm going to rewrite this radical as a rational exponent. That way we have just both exponents. So remember, roots are the same thing as fractional exponents. So instead of the square root of x, I'm going to rewrite that as x to the 1/2. And then now we can use exponent properties. So properties of exponents, whenever you're multiplying exponents that have the same base, you can just add the exponents together. So we're just going to add those together, 2 plus 1/2. Now remember, when you're adding fractions, you have to have common denominators. So if I want to change this, this would be 4 over 2. 2 over 1 is the same thing as 4 over 2. So when we're adding those together, that would be 5/2. So this would be x to the 5/2. And you can just leave it like that if you'd like. If you want to write it as a root form, you can do that. That's the square root of x to the 5th power. Either one of these is fine. So that would be the answer. That would be the product of f times g. All right, let's do the rest of it. It says state the domain. So let's think about the domain of this function. We have a square root function. The final answer resulted in a square root function. The original functions were a quadratic, which has all real numbers, right? But we know square root functions, the domain of this is not all real numbers because square root functions have to be positive. So the x values here are going to have to be positive numbers only. So we want our domain to be x is greater than or equal to 0 because we only want those positive values for x. Otherwise, it won't work. Now let's do our final step. They want us to evaluate this when x equals 9. So I'm going to do that over here. So f times g of 9 would equal, and again, I'm just substituting 9 in for x over here. So it would be 9 to the 5/2. If you think of that as a root, that's the square root of 9 to the 5th power, which would be 3 to the 5th power, which gives us 243. Okay, so that's how we do multiplication. Let's do a couple more examples. Go ahead and turn the page when you're ready. All right, so same process here. We're going to multiply these together. So we have x cubed times the square root of x. But remember, we want to use rational exponents here. So this is really the same thing as x cubed times x to the 1/2. So now we can just add these together. So 3, if I want to think of this as halves, right? 3 over 1, if I times those both by 2, that's the same thing as 6 over 2. So we're adding 6/2 to 1/2. That would give us 7/2. So that would be the answer. That's the product of those two functions, x to the 7/2. Now our domain, same process here. This is a square root function, right? So the original one was a cubic. This has all real numbers, But this has a restriction. So we're going to have to take our most restrictive domain here. And this final product is a square root function, which means our domain, again, is going to have to be x is greater than or equal to 0 because we only want positive values for x here. And finally, let's evaluate it. We're plugging in 4. So we're going to have 4 to the 7/2, which is the same thing as the square root of 4 to the 7th power, which is 2 to the 7th power. And you might need a calculator for that one, but it's not too bad. You're just doing 2 times itself 7 times, and that would give us 128. Okay, let's take a look at this next one. So we are multiplying these two functions together. So we have 36x to the 7/4 times 4x to the 1/2. Okay, so the nice thing about this one is that we already have both rational exponents. We don't have to convert anything. We're just going to add those together. But we also have coefficients here. When you have coefficients, you just multiply those. So you're just going to do 36 times 4, which gives us 144. And then for the variables, you're going to add up those exponents. So we have 7/4 plus 1/2. Remember, 1/2, we're going to change it to a common denominator here. That would be 2/4. So when I add those, I'm going to get 9/4. So we have x to the 9/4 here. And again, you don't have to simplify this. You can just leave it like this. That's as simple as it can get. If you want to write it as a root, you can do that, but I'm just going to leave it as rational exponents. Okay, let's think about domain here. So we have, and again, you could graph it if you want to. This is a fourth root function. And we know from this chapter that fourth root functions look very, very similar to square root functions, right? They have that same overall shape. So we want our x's to be positive. So we're going to have that same domain as before. It's going to be x is greater than or equal to 0. And finally, let's evaluate the function with 16. So it would be 144 times 16 to the 9/4. Okay, so we're going to do the root first. So think of this as the fourth root of 16 to the 9th power. So let's see, the fourth root of 16, that is 2. And then we have 2 to the 9th power. That's going to be a big one. You can put it in your calculator if you need to, or you can, we already know that the 7th power was 128, right? So then you could just double that 2 more times. But that equals 512. And we do have that 144 on the outside, so we're going to do 144 times 512, which is a really big number. So this should be 73,728. There we go. Okay, finally, we are going to talk about dividing functions. And again, it's pretty simple. We're just going to use exponent properties here. There is something strange, though, about the domain when you do division. So we'll talk about that in a second. So for now, we're going to kind of do this the same way we did multiplication. We're going to use exponent properties. But you have to be careful with domain here. So we talked about this on the front of the notes. I'm just going to leave a little note here. Be careful with domain. You just have to remember you can't divide by 0. That's something that's just not allowed. If you try to divide by 0, it's just not going to work. The function's going to freak out. So we want to make sure, like if we're doing f over g, right? We want to make sure that we don't include any x values that are going to make g equal 0. So we'll talk about that as we go through some of these examples, and you'll see what I mean by that. Okay, let's take a look at our first one here. We are dividing these functions. We have 4x and then x to the 2/3. And we're going to find f divided by g of x. So we're just going to divide those. So we've got 4x divided by x to the 2/3. Okay, so that would be f divided by g of x. Okay, so we're going to use our exponent properties here. Remember, this x has a 1 as the exponent, and we know that when you divide exponents, you subtract them. If the bases match, you can just subtract them. So we're going to do 1 minus 2/3. So this would be 4x to the 1 minus 2/3 power, which is 1/3, right? If we take away 2/3 from 1, we would just have 1/3. So that is our answer. And let's talk about domain. So when you're doing domain here, you have to consider the original setup here. Now we can think of this as a cubed root, right? We know that cubed roots typically have this shape. They typically have that all real numbers domain. However, we can't include every single number because we cannot let the bottom of this be equal to 0. So what you have to do is you have to look at the bottom of this setup here. So at the bottom of in the denominator of our fraction, we have x to the 2/3. I can't put a 0 in for x, because if I put a 0 in for x, 0 to the 2/3 is just going to be 0, because the third root of 0 is just 0. So that is the one number that x is not allowed to be. X is not allowed to equal 0, because the function won't be defined there. So for our domain, the domain can be pretty much anything else, right, because of this all real number situation, but it can't be 0. So we're going to just say that x cannot equal 0. That would be our domain. And finally, we're going to evaluate the function when x is 27. So we'll do 4 parentheses 27 to the 1/3. And 27 does have a cubed root. So the cubed root of 27 is 3. So this would just be 4 times 3, which is 12. Okay, so that's how we divide functions. Just be really careful with that domain. We cannot have values for x that would allow us to get a 0 in the denominator. All right, last two examples here with division. So let's take a look at this one. We're going to divide 6x by x to the 3/4. So this one's pretty similar to the last one we just did. You're just going to do 1 minus 3/4. So this would equal 6x to the 1/4 power. Okay, and then let's think about the domain for this one. This is an even root. This is a fourth root function. And remember, typically with even roots, they look something kind of like this. So usually the domain is x is greater than or equal to 0, which is great, right? We don't want any negative numbers in that root. However, we do have an x in the denominator here. And if I were to actually put 0 in there, the bottom of this fraction would equal 0 again. So we really don't want x to equal 0. So this little equal to line here, we don't want that for this one, because x can't be equal to 0. It can be greater than 0, but it can't be equal to 0. So for this domain, we're going to say that x is greater than 0, and we're going to make sure that we do not include that little equal to line under it. All right, and then finally, let's plug in 16. So this would be 6 times 16 to the 1/4. The fourth root of 16 is 2, so this is just 6 times 2, which gives us 12. Okay, we have one more example with division, and then we'll talk about how to evaluate functions differently on the next page. So here we go, dividing the functions again. We have negative x cubed divided by 2 cubed root of x. Okay, so since we have a exponent on the top and then a root on the bottom, this is going to be difficult to work with. So I'm going to rewrite this root using exponents. So instead of 2 times the cubed root of x, I'm going to put 2x to the 1/3, because that's the same thing. All right, so now that we have it written like this, we can just apply our exponent properties. All right, think of that negative sign as a -1. So this is... you can divide these if you want, but this is just -1/2. So I'm going to just subtract my exponents here. So we're doing 3 minus 1/3. Okay, and then let's see, 3 minus 1/3. If I change 3 over 1 into thirds, 3 over 1 would be 9/3. So if we're taking away 1/3 from 9/3, that would leave us with 8/3. So this turns into negative x to the 8/3 over 2, because that 2 was on the bottom. Or you could think of it like this, -1/2, because that's what this would be right here, -1/2 x to the 8/3. Either one of these would be okay. Okay, so there's our quotient, and now let's talk about the domain. So let's see what we have here. We have a cubed root, right? And remember that cubed root typically has a domain of all real numbers. However, we want to look at our denominator here. I cannot have a 0 in there, right? So that means that x can be anything except for 0. So for this domain, we're going to say x cannot equal 0. And that implies that it could be anything else. It just can't be 0. And finally, we're going to plug in negative 64. So let's go ahead and do that to, I'm just going to use this one here. Negative 64 to the 8/3 all over 2. And if you want to think of that as a root, you can think of that as a root. That's the same thing as the cubed root of 64 to the 8th power. And let's see, cubed root of 64 is 4. So this would be negative 4 to the 8th power over 2. It's going to be a pretty large number here. You can put that in your calculator if you want to. That is going to be 65,536 all divided by 2, which gives us negative 32,768. So that would be the final answer there. All right, we have one last thing to talk about, so go ahead and turn to the next page when you're ready. Okay, so this is about using a table to evaluate functions, and it's pretty simple as long as you understand how to read the notation and how to read the table. So let's look at each of these. It says f plus g of 1. So think of this as, we're adding the functions together. Think of this as the same thing as f of 1 plus g of 1. So if we evaluate the function at 1 for f, and 1 for g, whatever those values are, you would just add them together. So we're going to go over to the table and we're going to look where x is equal to 1, because that's what we're doing here. We're plugging in 1 for x. And that would be this column right here. So f of 1 is negative 4 and g of 1 is negative 3. So we're just adding those two together. So this would just be negative 4 plus negative 3, which is negative 7. And that's how you do all of these. So the next one is we're subtracting the functions, and we're looking at x when x is 3. So this would be f of 3 minus g of 3. So I'm looking over here this time. F of 3 is 10, and then g of 3 is negative 31. So we're doing 10 minus negative 31, which would turn into addition there. That's going to be 41. And finally, we're going to do multiplication and division. So now we're going to evaluate f times g of 0. So let's go look at the 0 section. That would be just negative 2 times negative 1, which gives us positive 2. And then finally, division, we're going to look at x equals 2 for this one. So think of this as f of 2 divided by g of 2. So let's go find those values here. That would be 0 divided by negative 13. And you're allowed to have a 0 on the top of a fraction. 0 divided by negative 13 is just 0. All right, so that's pretty simple. That's how you use a table to evaluate. That's it for the notes. You can go ahead and start your 5.5 practice sheet.